Good afternoon and happy Tuesday. Hope you're having a wonderful Tuesday and welcome. Let me introduce myself if you haven't been in one of my previous classes. My name is Alex Cooper. I teach the computer classes for the Columbia County Library in Evans, Georgia, and also the Harlem Library, Ucha Creek, now our new Grovetown Library building too. Of course, we're staying home and staying safe and everything, so we're just doing all our classes online and stuff, as this class as well. So this is kind of a fun class. We're getting down to our last week here in December. So we're actually doing a Raspberry Pi project with me, Alex. Hello. And we were going to change the project a little bit here. I had a little bit of a different one on the roster. Had some issues with that one, actually being able to get it to work. The setup on it, I'm still having to investigate, was not working properly on my Raspberry Pi, even though I followed the instructions many times. And that meant that some of the quintessential other projects on there actually would not work. So we're going to do a different one. We're going to do a basically a temperature gauge is what we're going to do, because we have our box of goodies. So let's go ahead and let's talk about other classes that we have coming up. And of course, let's go ahead and start off with the question I always want to start off with is, how can I help? Okay, what questions do you have? So welcome. And let me do one other thing. So let's talk about some of the classes that we did this month, and also the ones that we have coming up tomorrow and Thursday. All right, so we did Google School this month. We also did holiday coding, which was a lot of fun. So our plan basically is, we're doing our Raspberry Pi class today, and then tomorrow at 11 o'clock, join me for starting of our 3 holiday classes, and also we're going to be doing a gadget help as well. So the 16th, meaning tomorrow at 11 o'clock, come join me, because we're going to be doing our holiday coding with Python. We're going to make some digital snowflakes, okay? And then tomorrow afternoon at 2:30, we're going to be doing a Facebook Live. Be on Facebook Live for Gadget Help. If I don't get many questions with Gadget Help, I think I'll start talking about some of the free resources from the library, and also maybe throw in some stuff about some of our videos and movies and stuff that you can, the services you can check out with Acorn TV, and of course our Indie Flicks as well, for free through the library. And then on the 17th, we're going to be doing our Let's Make a 3D Snowman at 11 o'clock using our Blender 3D software. If you've ever wanted to get involved in doing some kind of 3D software, Blender is a great way to do it, and just follow along with our tutorial, follow along with me. And then on the 17th, we're going to be doing some animation with Blender, which is new. So if you want to do that, that's a fun project. And all 3 of those projects are actually from the Raspberry Pi website for Python, and of course for Blender as well. So let's talk about one of our new services from our library. If you're looking for free ebooks and free audiobooks, the best place to try first is, of course, your library. So all you need is your library card. You can download the Libby app. We switched over from RB Digital to Libby on the October 1st. After you install the app, make sure when it says what's your library, don't type in Columbia County Library, don't type in Grovetown, don't type in Harlem. Need to type in Greater Clarksville Regional Library System, and then choose Georgia download destination and enter your library card, and then you should be up and running. Little side note, our libraries are open with limited services and hours. Curbside holds pickup is available. You can go to gchrl.org for details, or call the library questions Monday through Friday, 10 a.m. to 5 p.m. Don't forget to like us on Facebook and subscribe to our YouTube channel, which you're on right now. Right now we're having a subscribe drive. If we can get 100 subscribers to our YouTube channel, then we can actually get our own YouTube address. Or search YouTube for GCHRL videos and it'll pop right up too. All right, so let's go ahead and back and let's focus on what we're going to talk about today. So I'm going to go ahead and I'm going to pull up. I'll give the usual handout I give out because we actually do a Raspberry Pi physical computing class at the library, and I usually pass out a handout. Hold on a second. Let me see. I want to share that. It wants to open it first, so just give me a moment. All right. Okay, come on. So as we kind of talk about what we're going to be doing today, also I'll be covering this a little bit as well. So here is the handout. And that is basically a beginner using Raspberry Pi with our Gpio pins and everything. And let me open that real quick. I know that a while back we actually did the music box one, which is pretty fun. Okay, so I'll kind of go over this a little bit. The main reason to go over this is because you'll get to see a little bit of the information as I try to teach this kind of like as a beginner, and then we'll kind of jump into, and I'll also get to make sure that my camera is working properly. Let me try that out real quick. All right, there we are. I'll move that down to the right. Yay, you can see me wave. Okay, and I need to turn on the top light. So let me do that real quick. There we go. That should help a little bit. So basically we have our Raspberry Pi here, and we actually have from everything on here currently from our previous project. So we'll be removing that in just a little bit. And get this isn't locking me. Okay, so got that ready. So let's zoom into this and we'll talk about our Raspberry Pi a little bit, kind of introduction. And I try to have as large as I can. One of the big things is in class, usually have a computer in front of everybody, and that's basically a handout. And the good idea is to have me in a separate device at home so you can follow along as well. So we're going to talk about a little bit about our Raspberry Pi connections, and then we'll start our main project here. But kind of get you started, get a little bit of information, maybe if you haven't done a project before, or maybe you're just following along. Of course, the big thing I like to say is first attempt in learning is fail. So be aware that that's probably going to happen. The code's going to be wrong. Your wires are going to be wrong. So just realize that. So we have our Raspberry Pi. We have our connections. Today we'll be using the Raspberry Pi 3. Okay. We have our breadboard. We have our operating system, the free Raspbian off the Raspberry Pi website. We also have our breadboard. Well, I already said that. Breadboard with us and our other parts for our project. Now we're going to be using the Mu software, which I'll talk about that in a minute too. we have our Raspberry Pi Gpio Pins. So this is the big thing to talk about, because on our Raspberry Pi, now the setup I actually have, of course I'm pointing and y'all can't see, hold on. There you go. On our Raspberry Pi, the Gpio pins are actually right here, okay? And with this, I have it connected up with our ID cable here to our breadboard, okay? Now, do realize one of the big things is to have it so that, do realize that our Gpio pins, there's mainly 3 different kinds, okay? There's ones that have power, there's the ground one, and then there's general purpose. Now, it may give it different names or whatever, because some of our projects may do that, and also our projects we're doing with this specific, and I'll talk about that in a second, group will actually use code that actually, instead of using the normal Gpio pins, if you've done projects with the Raspberry Pi, it actually just changes it to the numbers of where it is on the board. So I actually have this nice little cheat sheet here. I don't think there's anything back now. Nice little cheat sheet here that actually shows the Gpio pin numbers, their other names, okay, aka, but it also shows the numbered pin on the Gpio that way. So it depends on which one you're working on, okay, but you may need something like that, and I do have a little resource there that's listed, and that's on knikit.com/quick-start/pi, okay. So a lot of the projects can be found here, right here. So let's talk about, here's our Gpio pins. They have numbers, they have GP means general purpose. So general purpose input output, okay? Now the big thing is when we talk about connecting our wires, we need to realize there needs to be a ground, okay? So basically this is our LED that we have set up here, okay? And then we have our long leg, short leg. Long leg means electricity flows that way, okay? So we have our long leg, short leg. We have our resistor, or you could say fuse, to make sure electricity doesn't get too strong. So we have our positive flow through. If there's no switch here or button, then it's connected automatically, but you could have a button like this one where you press it, it closes the circuit, electricity goes to ground. This has to happen for the projects to work, okay? Positive to negative, positive to negative. Now, how do we connect stuff up by not having to solder it? Well, we have our breadboard. Yay, our nice little breadboard here. So we look at our breadboard, just realize that it does have different sections. This middle part doesn't connect anything. All you do is we put our wires and put them into the holes in there, and then they'll connect. The rows are this way, okay? The rails are this way. This is mostly if you're going to have something connected up, one thing to the ground, one thing to power, and you have everything else connected to it, okay? So I think we're about to remove all the wires I already have on there. So just realize that's how that works. Try to match it the same row, okay? And it's just like connecting the wires together or soldering them together. And then we have our rails as well. Okay, so now that we've kind of covered that a little bit, let's go ahead and let's jump in. And I'm actually going to connect to our Raspberry Pi. All right, so let me close that. So here's our Raspberry Pi, okay? So I'm connected to it virtually so that you guys can see it. All right, and on here, I'm actually going to open up and we'll talk about how our project began. Well, basically, been teaching the basic Raspberry Pi with LEDs and everything, and making a timing game and everything, but I actually purchased a free, it's called Free Nova or Novi RFID starter kit for Raspberry Pi. It's the FNK0025 model. Okay. I think it was just $40 on Amazon. They have a few of them, and I actually wanted something that had basically all the components I was kind of looking for. But one of the big things is that not only does it include the components, of course, wires and everything. Everything I'm going to do today came in this box. Not only did I have all that, but I also have things for future projects, and that's kind of how this class got started. Just wanted to come up with some future projects to do some fun things with our library, and be able to, maybe some new things we could use in some new classes in the future. This is actually have a RFID reader on there. We have some key buttons to put in, some servos, motors, joystick, LED screens, all kinds of fun stuff. And the cool part about it is everything that's in here, there is a project for it on the Freenovy website. And to be able to get this tutorial, just go to tutorial.freenovy.com. That's FREENOVE.com, and they allow you to download it. Okay. All right, so we have all our stuff here. Let's go ahead and let's open up our project. And all I'm going to do is I'm going to open up the Freenovy starter kit that we downloaded. And the thing we're going to use is called tutorial. One of the reasons I load this on the Raspberry Pi is because it'll make it a little bit easier later if I have to enter any kind of code. It's kind of easier just to, where's my zoom? I guess that would work. Okay. I can just copy paste code. So let's look at our list here. So which projects have we done? The LED one. We've done buttons, LEDs, LED bar graph, analog one, and the one that we had buzzer, we did the RBG LED, and this is the group that actually has given us trouble right here. I want to say pentameter, but I think I'm saying that wrong. But basically, it's a I guess normal people would say it's just like a volume control, but had issues actually getting that to work on this Raspberry Pi. So we're going to go down here, and we're going to work on temperature. Okay. Let me make sure I'm going to say that right. That's funny. All right, so we have our thermometers, and we're actually going to talk about different types of thermometers. And we're going to do one electronically. So let's go ahead and let's get our project together here. Whoop, I clicked the wrong thing. Hold on, it jumped on me. Sorry about that. Hold on, sorry. Okay, so let's look at our circuit. I hope it's not too jarring to have the two screens on there. All right. I want to call that a thermistor, but there's the let's see. Okay. I guess that deals with thermostat. Let's see.
Thermistor.
Thermistor. Okay. Good old thermistor. All right. In this chapter, we can learn about thermistors. Okay. I guess that is part of, let me see here. Anyway, so it's going to gauge temperature. Thermistor is a type of resistor whose resistance value is dependent on temperature and changes in temperature. Okay. Therefore, you can take advantage of this characteristic to make a thermistor. Okay. All right, so let's look and see what we have. We need to have one of these. We also need to have one of our resistors. This is the same one that we had with our previous project. So I'm going to go ahead. I'm going to take out all our wires here. And we've got the one that we have on here is actually the AD one. Okay. I2c module, and I should have the thermistor. I was like thermos. I'm sure it's not in here though. Okay. It looks just like a little dot on there. I have ones on here that are brownish, but I don't believe that's it. Look at my charts. Nope, that's not it. Okay, let me pull that up to make sure I know what that looks like. Here's my little component display, and it is, yeah, that's not the same thing. Thermistor, okay. Oh, there it is. There's our other bag. All right. There it is. I see it right there. Okay. It looks like a little dot. You see that? It's like just a little dot. So I'll set that there. And I only have one. my little kit. Okay. All right, now let's keep going. We already got our jumpers, and we need a 10K resistor. Let's see which one are these. Okay, so our 10K. Okay, so that's a 220. I think that's a 1K right there. Yep, and that's our 10K. All right. Oh, I need 3 of those. Okay. So there's one, and I actually have a bunch over here in my little kit. So. Okay, so let's keep going. Talk about our component knowledge here. Thermistor is a temperature-sensitive resistor. When it senses a change in temperature, the resistor of the thermistor will change. It sounds like some kind of new, get the new thermistor. It'll really help you when you're hot in the summer. Thermistor will change. You can take advantage of this characteristic by using a thermistor to detect temperature insensitivity. A thermistor and its electronic symbol are shown below. I'm not even going to try to do some equations here. We're just going to kind of read over it. The relationship between resistance value and temperature of a thermistor is, okay, it's temperature resistance under normal resistance. Okay, ninth power, show up kelvins. Okay, temperature gauge. Celsius temperature, and it's showing a chart. Circuit connection below of the thermistor similar to the photoresistor as the following. We can use the value measured by the I2c converter to obtain the resistance value of a thermistor, and then we can use the formation to obtain the temperature value. Therefore, the temperature formation can be derived as, and it shows it right there. And ours is not the PCF, ours is the ADS one. Okay, circuit for ADS. The circuit of this project is similar to the one in last chapter. The only difference is that the photoresistor is replaced by the thermistor. Okay, so that's what we got to set up. And I'm hoping that this, because remember I had issues with the previous 3 LED classes because I couldn't get them to work, was based on that there's certain software that couldn't get installed. So hopefully we will have an outcome with this. But just realize that if it is using some of the same software, we may have an issue where it doesn't want to work. But we're going to try our best. This is trying stuff out. So here we go. All right, so I'm going to try to choose the same, I'm going to say cords, same wire color as in the graph here, so it'll be a little bit easier All right, I got red. Let's see, I got green. And let's see, green, red, and I think that's another green. Let's see. All right, let's go ahead. All right, so we got our green. Let's get yellow first. So yellow, SCL1. And we're going to plug that into the SCL. Okay. SCL blue will be the SC. Anyway, the second one, SDA, I believe. And SDA1. Whoop. That is not a double male. But this one is. SDA. And then SDA1. Okay. Now we need red for 3 volts. And maybe we'll put that one on last because that is our power. Our ground is they decide to be green. So we have our, it doesn't want the green on the ground on the end for some reason, but I'm following their instructions. The ground should not matter. And it wants it to be on the negative rail. Okay. And then our other ground connecting up to our circuit board right there. And that goes negative. Let's see, red is the end there. And that'll plug into the positive. And then we got this other red. Well, let me get it. I guess I need another one. All right. So we got this red, and it looks kind of black. Or is that green? I don't know. I'm going to go with this one. It's okay. All right. So we need to get our photomistor. Excuse me, thermistor. I guess it doesn't have a positive and a negative. I mean, like the LED, which way it should flow. And I'm going to put it. Let's see. Huh. Okay, so it's basically going on the same row here. So now it is connected to that board. Okay. But then they also want me to connect. Why did it say I needed three of the resistors? Because it only shows one on the graph. Maybe I read that wrong. All right, so we're going to go right here. And then we'll go on. Let's see. We'll go on right here then. So this should actually be showing, touching on the same row as the, which one is that? The AO, I believe. Okay, now we need red. We need a black first. Black. And why does it, okay, so this is on the same row as that. It's an interesting way of doing that. And then that's going to go to ground. So basically we have the thermistor connected to the board already, but it also has a resistor here. Okay, and then red is going to go to there, and then going to go to positive. All right, now I need to have a red. This will be for the power, so everything should be lit up. Last time we did this, the I2c board actually has a light that turns on, or an LED light that turns on. So 3 volts, and we connect that to the positive, and then boom, the I2c now is lit. Okay, it is fire, it is lit. Okay, now all right, the code we're going to be doing, of course. All right, so here we go. In this project, the I2c value still needs to be red, but the difference here is that a specific formula is used to calculate the temperature value. Now, we're not going to be doing C. Oh no! Okay, so we might have an issue here, because it may make me go back, and because I could not get the previous project to work, we may have to focus on trying to get that to work. All right, so here's our Python. All right, so we're going to run our tests. So it talked about if you did not configure the I2c, please refer to chapter 7. If you did, please continue. First, observe the project results and learn about the code details. So this is actually one of the things, either I got it to work and our main section still did not work. So not really sure why on that. But we may have to go back and troubleshoot if this does not work because of the previous value. The previous was not set up and installed properly, okay? All right, so use the C command to enter the Thermistor directory of the Python. Okay, so I know where that is. And we're actually going to run the Python. And after the program is executed, the terminal window will show the current I2c value, voltage value, and temperature value. Try to pinch the thermistor without touching the leads with your index finger, and in a brief time you should see the temperature value raise. Okay. Okay, so there's our code. It's going to run. In the code, I2c value and module A0 port is red, and then calculates the voltage and the resistance to the thermistor according to the Ohm's law. Finally, it calculates temperature sensor by the thermistor according to the formula. Okay, and then that's the end of our project. Okay, so let's go back, and we're going to try this. Now, if it doesn't work, we may have to go back and troubleshoot the previous chapter, chapter 7, because partially, like I said, I couldn't get some of those things to install properly, and it may be an issue where there's been software that's been updated. It's not compatible with the way I was doing it. Okay, so we're going to run this right here, and I'm going to scroll up. Oh, I have to be in the proper directory. Okay, the easiest way to get there is do it this way. And then we do code, Python code, and we are... Oh. If I double click it, will it run it? Maybe. Oh, it opened it up in mute. I'm not sure if this would work. We're going to hit run anyway and see what results we get. Okay, so we're not going to have to be able to do it that way, at least for now. All right, so let's tell it to, I could do a bunch of switching like it said, or I'm trying to remember what do I do here. There it is. Open current folder, and it'll save us a little bit of time. All right. Oh no! Program is starting. No device address at 048. Not found device and address. Okay, so we probably, oh, there you go. I2c address found. Please command detect Y to detect the address. Okay, so I2c detect minus Y1. Yeah, so this is one of the issues I kept trying with the 7 to get to work, and then my ADS doesn't read anything. So I'm gonna have to go back and I'm gonna have to troubleshoot that. So hopefully I can get that taken care of in just a few minutes here. We'll continue with our project. If not, we may have just come to a standstill about our main project here. Okay, so I'm gonna have to go back to chapter 7 and our tutorial, chapter 7. Okay, so the big thing is we have our components plugged in. Module ADC is plugged in. The light is on. Okay. And ours is 30 at the end. Okay, let's see if we can run our software and hopefully get it to read. Hopefully I don't have a bad one. That's possible. Come on. Okay, so I basically have the same, let's see, as I set up the same here. So we have the yellow. Let's see. So the green has power. Now, is that more about it can't, the software is improperly installed? Let's see. So the I2c interface Resistor is disabled by default. You need to open it manually and enable the I2c interface as follows. Resify command, resify sudo resify config. Okay. And then we go down to where it says choose 5 interface options. Now I know this is actually changed on our menu. Then hit yes and finish. P5 in order to restart your Raspberry Pi. And restart your Raspberry Pi, the I2c module will then be started. Type a command to check whether the I2c module was started, which is this right here. Okay, so go down, and I know this menu has changed, so just give me a moment. Let's see, so it's not, because they say it's, what was it? Yeah, choose 5. Things have actually changed here. Let's see. There you go. I2c enabled. ARN I2c modules and hit start. So hit yes. It's enabled. Okay. Now so then I go finish. All right, I'll type in the same. Oh no, I want to type in the check. And it says BCM2835. Let's see, and R is all the way back up there. Okay. Oh, sorry. As the ADS 7830. Okay. Okay, so it comes back with BCM 2835. And a tutorial says if the I2c module has been started, the following content will be shown. BCM 28 is a different number versus CPU model. Different models, Raspberry Pi display different contents depending on the CPU installed. Okay, so that is getting something, I guess. It's not getting an error message. Okay, now install the I2c tools. Next, type the command to install I2c tools. It is available with the Raspberry Pi OS by default. Okay. You already have the newest version. I2c tools is already the newest version. Okay. When you are using the PF, hang on. So when you're using the results should look like this if I'm using the ADS one, which is right here. And it has nothing. It shows nothing. Okay, so this is basically what I was having the same problems with before. So I get nothing. So this is completely blank. I will do this just in case. It says it's already been installed. Okay, so let's see what is actually happening. So the main thing here is when I type into the text, I don't get anything back. Now, I know I've rewired it for the second project, but let's go back and reread. All right, let's see. So with this project, we actually have it wired up with the Thermistor. this, let's see. So I guess I basically need to recreate this project and then see what we can troubleshoot here. So what is the actual board connected to? So it's actually connected to this SDA1 and the SCL1, okay, and the SDL1 connects to the SDA, okay, which is glowing. Okay. SDA, SC, SCL. And that's connected to the SCL. And then that's connected to the SDA1. So it's kind of like, okay, if it wouldn't work at all, I unplug this. So how can we see if it's getting any kind of message from the ADC? So it's the ground. It's getting voltage. This is where it actually is getting its power from. This project's kind of wired up similarly. So, whoop. Okay, so the V, where it says VCC, goes to power. Those go, the ground goes. Okay. Make sure something weird hasn't happened, like my metal teeth have gotten bent. Let's see. Our 3 volts. There's our ground, which turns everything off. Ground comes out, connect to the ground rail. Okay, this comes from the VCC, connects to positive. Whoop. It rebooted for some reason. Okay, I gotta reopen that again. see. So this is the one that we have. I2c is two-wire serial communication mode, which can be used to connect a microcontroller and its peripheral equipment. Devices using I2c communications must be connected to the serial data line, SDA, and serial clock line, SCL, called I2c bus. Each device has a unique address which can be used as a transmitter-receiver communication device connected to the bus. So that's what SDA is. And that's not the one we have. Okay, so if I have the other one, that's when I have to use the resistors. Okay, I guess I'll rewire this. Got that 3 volts, SDA1, SCL1, SDA goes to the SDA, SCL, and then we have our ground, and then we have our ground, and then this has the VCC, power, and then this connects to the A, which is the middle one. It's the AO, okay. Okay, so, sorry. Oh, I rewired it and you didn't get to see it. I'm sorry. Okay, so I just rewired it. And I put our control back on. Let's see. Okay, now. So we did this. I know it's installed. So let's check, see if it started. Because it did restart a minute ago. Okay. We know the tools are there. We need to detect it. And again, we get nothing. Okay, let's see. So we already installed it. See, already the newest. So we should be getting some kind of something on there. I need to turn this or something like that, do I? Okay, I'm just going to do a search real quick and see if I can nail this down a little bit. Oh. Okay. Let's see. So basically, one of the boards, someone is actually suggesting doing a Gpio Pin Test. It says if you have damaged one or more GPIOs, you can carry out a diagnostic test. This test is a bash command line script. Test requires the surface's GPIO library. For the duration of the test, nothing must be connected to the Gpio pins, no LEDs, wires, or ribbon cables. The test checks that each Gpio pin may be read and write, and then the internal resistor pulls down are functional. The video shows it happening. Gpio Pin Test. This test, I test with all Gpio pins okay. Wow, okay. So, let's see if I can load this. Okay. so nothing connected. So I will delete the pins here. I mean, not delete. I'll remove the ribbon. And figure out how to run this. Okay, so that's funny because I didn't see the bottom of the page there. I couldn't see that I'd already downloaded it a few times. That's funny. Okay, so downloads. Get to extract it, I guess. All right. Why did it close? And then, okay. No, that's the test. Okay. Maybe I can't do it with a double click. Maybe I have to go there to run it directly. Okay. Okay, I'm not sure what I'm doing here. Oh, now it looks like it's frozen. Yes. Okay, so I run it, asks me all the questions, then it tells me to hit enter to continue. I hit enter and it closes. Then it doesn't give me any readout or anything. So, okay, let me see if I can find another way to test. Okay, so do I have to have this installed? Okay. No. this. Okay. Okay, so it just still just closed, so it gave me nothing. Huh. Okay. It did say testing. At least that time it did say testing. And then it exited. Testing, exit. Yeah, okay. So, I don't know what I'm supposed to be doing. But clearly these little projects require that to be installed and running. And I might have some kind of issue going on. I know that there was another, we were using the LED to do the waterfall, and one of the pins didn't work. And I do remember that being quite odd. And I actually had to bypass and rewrite the code to make the waterfall LED project to work. So we may actually really have one of our little Gpio pins not working properly. I'm trying to remember, this is a Raspberry Pi I've had for a while. I believe this might have been the ones I was using as a video player. So let's see. And we'll try that real quick. Make sure it's installed the way it should be. Okay, installed. There you go. Testing, and then it closes. LB? No, LS. Okay. It's downloads. Okay. It's capital D. Yep. Okay, and it's Gpio test. Diagnostic test requires that command line. Test is a bash command line script called Gpio test. For the duration test, nothing by speaking at LEDs. Test checks each Gpio pin and reads writes the internal Is it pulled down or functional? It says okay. It says testing, and then it should give a readout. Okay, I found somebody else that says it just closes for him. Can't see result because it automatically closes after a second. Someone said the second person mentioned that it fails on a Pi 3. First, it works okay for me. So, found a forum. There's a lot of people that are just discussing that. They have tried this and it doesn't work. Okay, then some people do. Okay. Aha. Okay. Of course, we have a fail. No. Now, where did I get that from? I don't know. I'm not that familiar with Linux. I basically just searched for a message board that said to run a command in the local directory, you have to use the form /command. It's a security measure. But of course now it says it tested all the pins. Let's see, which was there one of those that we were using? Okay, there's power. I guess these are the power ones or something. Let's see, power. Okay, I'm not sure why that skipped those, but it does say there's failure. User Gpio pins equals none, so at least we have done that. Let's see here. Okay, well, we did get our pins checked to see they're not working. We still have not found out what the issue is, why our tutorial is still not coming up properly. Now I've completely disconnected here. Might be a problem with something else somewhere else. Maybe it's a cable, maybe it's a plug, maybe there is something wrong with the ADS. I do only have one, so it's not like I can just check those with something else. So I will be testing this more. I actually do not have another class like this scheduled for the rest of the year. So I will have a little bit of time to mess with this, try to get it to work. But maybe you can go further trying to get this to work. I want this to be more of a, we walk through the tutorial, we learn something new together, but having the issue where the software is not working that our tutorial has told us to use is a big bummer, and trying to get this to work and it not wanting to work is very sad too, because apparently it's about 5 or 6 projects here that depend on having this working. So oh well, I have to leave it up to, I guess, you, dear YouTube viewer. To maybe try to figure out exactly what I've set up wrong, or maybe there is something wrong with the software in some way. Trying to install it, still just can't get a read back from it. But I'm going to work further on it and hopefully get it done. Like I said, my goal was to actually have all those tutorials, since I have a nice, box of goodies here. It kind of makes me not sure about moving forward with the Raspberry Pi projects, and it'll have to be more of a, I choose them, I work through them, and just only a few will be covered instead of just trying to walk through all of them. Okay, so Sally, we didn't really get that one to work. Okay, I hope so. Good, I hope so, Mac. I'm glad you're here today. So I think we'll go ahead and bring class to a close. Maybe better luck next time. So let's talk about what classes we're going to be doing tomorrow. Only 2 more days of classes for the year. Wow, can you believe it? Absolutely, 2 more classes for the year. So tomorrow at 11 o'clock, I'm going to be doing the Digital Snowflakes class again, coding with our Python, which is a lot of fun. That'll be the last time for that class, so come join me for that. And then in the afternoon at 2:30, we're going to be doing a live Gadget Help with Alex on Facebook Live on the Columbia County Library in Evans Facebook page, so come join me for that. And if not, if I don't get a lot of questions, I'm actually going to talk more about our resources, free resources from the library and other recommendations and stuff. And then on Thursday, we're going to be doing at 11 o'clock, we'll be doing our Let's Make a 3D Snowman, which is a lot of fun with Blender, and we give him color and stuff. And then in the afternoon, we'll be finishing up with our last holiday class, which will be Holiday 3D with Blender, animate a snow scene. So we're going to animate a car driving through a wintry town. So if you've ever been interested in doing some kind of animation or anything, this is the right class to get involved with. And I'll be following our Raspberry Pi tutorials, so you can be able to follow through that pretty. And it's a lot of fun to help you get started. On a side note, our libraries are open with limited services and hours. Curbside Holds Pickup is available. You can go to gchrl.org for details, or call the library with questions Monday through Friday, 10 a.m. to 5 p.m. Don't forget to like us on Facebook and subscribe to our YouTube channel for updates. Remember, if we can get 100 subscribers to our YouTube channel, we can get our own customized YouTube address. Or you can search YouTube for GCHRL videos and our channel will pop right up. So thank you so much for joining me today. I know that we kind of did a bunch of troubleshooting and stuff. We got part of our project to make sure our Raspberry Pi was working right, but then we didn't accomplish our final goal. But maybe in the future we'll be able to pick that up again. So thank you so much for joining me. I look forward to seeing you in our other fun classes, our Blender classes, of course our gadget help and stuff as well. So have a great day. See you next time. Bye-bye.